Now let's go ahead and open Linode. So linode.com. Okay. Now let's sign in. Let's log in. Okay, we logged in. Now let's create a Linode server. We have the IoT masterclass from the last class, and here we have a Docker environment that I'm running. Okay, so let's just create a Linode. Create a Linode. Now we could create any Linode with any of this OS operating systems, right? However, we need to create a Linode and then install Docker in it, right? So might take a while to get all that done. So like you have to create the Linode, then you have to log in, then set up the Docker environment and all of that. Now, instead of doing that, we could create a Linode that already has Docker installed in it. And one of the best ways to do that is to go to Marketplace and then search for Docker. And here you can see there's a Docker environment here. So we're just going to select that Docker. And now it's asking that we create a limited user for this Linode. So I'm just gonna create a user root 1. Now you can't use root, right? Root is already gonna be the default user for your Linode, right? You already have root there, right? So you need to create another username for the account that will have the Docker installed in it, right? And so for that, we're gonna use root 1. Now let's set a password. Just give me a second. Let me set up my password. Okay. Now we've entered our password. Disable root access over SSH. No, because we want to be able to log in using this root user, right? We want to be able to use SSH to log in using that particular user, root 1. Okay, SSH public key that will be used to access the Linode, right? So it'll be great to use a SSH key, right? But for this, we just want to do something quickly. If you watched the last video, you would see how we used SSH key for logging in. So it's very similar, right? Just do the same thing and paste your key there. But for this video, we just want to log in plain, just because we don't want to waste time. But again, this is not safe. It's safer if you have an SSH key, right, that you use for access. I would not recommend this for something that you would put on production. Please use a SSH key if you're going to put something on production. This is just for test, and I'll be deleting this right after this video. So again, if you creating this, you can generate the key on your computer and then copy the key information and paste it here so that you can be able to use that to log in, right? Again, the steps to do that are in the last video, and you can watch that and know how to do that from there. Your API token, we don't have that. We don't have DNS records. We don't have any domain name right now. Okay. There's only one image provided, so we'll select that. Our region, let's pick Atlanta. And CPU, these are a little bit expensive, right? So let's pick a shared CPU. And Linode 4 GB. That looks good, right? Okay, let's try that. Now, a Linode label, right? So let's create a label for this. We would call it Docker IoT masterclass -1. Docker IoT masterclass 1. Okay. We don't need any tags. Root password. Let me enter this is for a root user. So we added the password for our root 1 user previously, but now we are adding the password for a root user. So now Okay, again, I would recommend that you use SSH keys. So please watch the previous video to know how to use SSH keys and how to configure that. It's pretty easy. We already have it configured here. I just said, but for this video, we're not really gonna be using this on production. This is just for the sake of this video. So please just try as much as possible to use. I would 100% recommend that you use SSH keys. Firewalls, no. Attach a VLAN, no. Private IP, no. Now let's create the Linode. So it should take about maybe a minute to completely install our system. So just wait a little bit for it. While it's installing, we can go ahead and open Visual Studio. We'll be using Visual Studio to connect. So let me open up my Visual Studio. Visual Studio Code, okay. Now, okay, now it's booting, okay. So if you remember from our last video, right, we were able to connect, we installed the remote development extension, right? So you probably want to go here and just type remote. And you should get this remote development extension. I've already installed it, so you can see it's installed. It will give you the option to use this remote SSH, and this is really what we need because we want to be able to use Visual Studio to connect to our server, right? Once you install this, you should have this icon at the bottom here, this blue icon here, and you'd be able to use that to connect, right? So again, let's see if our server is fully connected at this point, right? So here is our server. It's fully connected. So now let's SSH into our server, okay? So I'm going to open Visual Studio Code, right? And then we're going to click this icon down here for open a remote window, right? And it'll give us these options. So let's click connect current window to host. If you click connect to host, it will open a new tab, right? Now our configuration is not here yet. Configure SSH host and then pick the first one right here, right? So that should open up our configuration profiles, right? Now our config profile. So we'll copy this and let's create a new one here. You can call it anything. So we'll just call it IoT Docker 1. IoT Masterclass. IoT Masterclass Docker 1. Our host name, we'll just copy that from here and paste that in there. And our user, remember our user is not root. We don't want to log in as the root user. Our user is root 1, right? So now this is saved automatically. I have that set up to be saved automatically. So now let's try connecting again. Okay, so now we'll go to connect current window to host, and we'll go to IoT Masterclass Docker 1. And now this is the first time we're connecting. So it says this has a fingerprint of this. Are you sure you want to continue? Yes. And now let's put in our password for root 1 user. Yeah. Again, it's asking for a password. Let's just open our terminal. Okay, you can see here that we are connected as root 1. So you can see here in the terminal, we are connected as root 1. So what do we want to do next? Now we want to create a directory for our application. So if you look here right now, there's really nothing in there, right? So let's go ahead and create a directory for our application. So let's run mkdir, right, to make directory. This is a Linux server. And we'll create a directory called applications. And so now we have a directory called applications, right? So there is a directory called applications there. Now let's just go to that folder. So what I like to do is I'll just connect to that folder on this side tab here, right? So let me open a folder, and I want to open applications, and okay, so it's gonna ask for the passwords all over again, unfortunately. That's how it works. I trust the authors. Yes, I trust the authors. Okay, I think I'm logged in. Yep, I'm logged in applications. All right, so now we are in the applications folder. Now to manage our Docker environment, one of there is a tool on Visual Studio, and that's one of the reasons why I love Visual Studio. It's really cool, to use it. So there's a tool for helping us use Docker, right? So we just want to confirm if Docker is installed. Now we could just type Docker here to check, right? And we can see that, Docker is there, right? So usage, Docker command, self-sufficient runtime. So we can see that Docker is here, but we need a tool to help us manage Docker, right? So that we can see things and not have to type command line stuff all the time, right? So let's go back to our applications right here. And I'm just gonna search for Docker. I think this first one, Docker by Microsoft, This is a really great tool. So we're gonna go ahead and install this. And now that we've installed this, you would get this icon down here, right? Let's click on that icon, right? So now one of the things you notice is that it's not really able to connect to our Docker. This might or might not happen to you depending on how, it's just the way things are installed. I think the user root one was not really added as a user to the Docker, and even though the user has access, it's not fully configured. So one of the things we're gonna do is we're just gonna run a command. We're gonna run sudo user modify, let's use a mod, ag docker user, right? So let me copy that and just paste that. So just for clarity, let me do this so you can see, and I just paste this here. So again, it's sudo space user mod, all in lowercase, space dash lowercase a, uppercase G, docker, in all in space docker, all in lowercase. The Docker is all lowercase, space the $, and then user, all in caps. So this will add our current user to Docker as a main user. Now it's asking for the sudo password. Okay, so now our user has been added. Now, fine, it's still not showing here even though we refresh it, right? So we're still not able to connect to Docker from this. It's just this tool is really great if you have it, and you would see why as we move along. So what we're gonna do is we're gonna go back to our Linode website and just reboot our server, right? So that all those settings will take place when next it boots, right? So let's reboot this, reboot Linode. This should disconnect us, right? So I'll be back. Just give it time it should probably take a minute to boot, and I'll be back. Okay, our Linode is back up and running, right? Let me go back here. We should have lost connection, right? When the Linode was rebooted, right? So let's just go and reload the window. Probably have to put passwords all over again. Okay, and you can already see that there's a getting started with Docker container already showing up. Like things are already being connected. Like you can even connect to a Docker registry if you have a Docker registry account that you want to use and download stuff from, right? If you have image, you can upload. You can see all the images. You can see your images that you have. You can see containers. You can connect to you can even see your networks and your volumes, right? So if these are the pre-installed ones, right? The default options, right? So basically it just simplifies it for you because you can see everything right here. And it just makes your life a little bit more easy, right? So let me open this tree. All right. Now let's go back to our application here. So now we need to download our code, right? We need to. So previously in the last video, we downloaded the zip for our code, and then we then just dragged and drop that zip here, right? And then we ran things from there, right? For this, we're gonna try something a little bit different. Now let's go to Let's Code with Francis. That's my Bitbucket account, right? So bitbucket.org/Let's Code with Francis. So now let's open that. That should give you everything that I have on my account that is public, right? So this is the Docker IoT connector for Raspberry Pi. This is the Docker IoT connector for API. This is the Docker IoT connector for the Event Hub. And this is the Docker IoT connector for the dashboard. So we want to install the connector for the API, for the Event Hub, and for the dashboard. So first, let's do the API. So let's go here, right? And we will copy the HTTP. Don't copy it up until the master. Just copy that, right? Docker IoT connector API, right? So now we will go down, and this Visual Studio is really nice. We'll go down to Git here, right? Oh, okay, sorry, it doesn't give you the option. Okay, so we'll just go to the welcome page. So go to welcome, and there's an option there for clone Git repository. So if you click that, we'll paste that URL that we have. Didn't I copy that? Thought I did. Oh, it's located. So let's go and copy the Git URL. All right. So we'll come here and then copy this. And now let's click on that again. So clone Git repository. Paste the URL there. So just copy the URL, Let's Code with Francis, bitbucket.org, Let's Code with Francis, Docker IoT Container API. So now let's click enter. We have to select the location. I want it in the applications folder, and then okay. And now you can see here that it's in our applications container. Would you like to open the clone repository or add it to the current workspace? I'll just click cancel for now. Right. All right, so we have the first one downloaded, right? We can just rename it, right? Or maybe when we have everything, we can rename them. All right, let's download the next one. So we'll go back to Code with Francis, and then we just took the API. Now let's take the dashboard. Let's clone the dashboard. So let's take the dashboard, copy that. Now we'll click on clone Git repo, paste that there. And now let's click OK, select our location. We want it in the applications folder. And now we're done with that. So that also has been added. We're just going to cancel this. So now we have the API and we have the dashboard. Now the next thing we want is the Event Hub. All right, so let's download the Event Hub. So let's open the Event Hub. We'll copy the URL. And then we will just click on clone Git repo, paste the URL here without the /src/master, just ends at the Event Hub there, right? And then click on clone from URL, right? And then applications, and we just want it in the applications folder. So, okay. So that's there, right? So we can cancel. So let's rename these three, right? So, okay, cool. We're almost there. So Now, the next thing we want to do is we want to run our applications, right? We want to host our application. So let's start from the API, because it's from the API, everything else connects to the API. So because once you start, everything else will fail if there is no API. Now, we could run one script that launches everything, but for the context of this video, we'll just launch it one after the other. So I'm gonna cd into the connector API. Now I'm going to run, so let's go back here. We're gonna build and run it, the command. So we're gonna use this docker compose project name equals IoT masterclass docker compose YAML. Right, so we have our compose YAML, and you can learn more about Docker. A lot of tutorials out there about Docker that you can learn about. So first we are going to build the application, and then we're going to launch it. Right, so let's build. Our application is building. Everything looks good, right? I think. Let's wait and see. Okay, so our application is built, right? And if you go here now, you can see there's all these images that we have. We have an API service. So the way the application is designed is there's an API service that combines all the API services together. And it's just for testing purposes. If you wanted to use all the applications in one place, right? You wanted everything together, you can use this one central API service. And we would look at it after we launch it. Then there is an authentication API service that's a hosted service that will only contain only the auth pieces, right? Then there is a device API for device related APIs, groups APIs, that's group related API, telemetry API, user API service, and the WebSocket. Now, if you remember from our design, so we talked about it where we had our firmware management service, our telemetry management service, so that's our telemetry service there, our device management service, this is our devices API service here, our authentication management service, which is our authentication service here, right, our user service, right, which is our user service here, and our WebSocket service, which is the WebSocket service down here, right? So all these services are hosted differently in their own Docker container. And if you want everything on the same container, I also just, if you wanted to test and you wanted everything in one place, you could have that also. You could have one container hold all your services as just one huge massive API service, right? The application does give you the option to configure these so that you can use and select whatever you want, right? So let's go back again. So we want to now go back here. So there's a second command to build up, right? To host our system, right? So let's copy that command, and now let's paste that here. So that is Docker Compose, because we're using Docker Compose, right? Project name is IoT Masterclass, and we want everything in the same project. That's why we're specifying which project name it should go to, right? And Docker Compose YAML up build. This is just a longer form of it. There's shorter forms, but because we want everything in the same project, we want to specify that project name, right? So once you run this, and if you look at it was open initially. So you would see our containers starting to load up as they come up. There we go. Now you can see our containers are starting to be loaded, right? And right now they are all loaded, right? Cool. And basically we have everything hosted, right? Now let's open up one of these APIs. Bring this back up. If you look at the Docker Compose, right, let's start from there. Let's go back to our connector API, right? That's the one we just launched. And we go to our Docker Compose. Now, you would see here that we have our MongoDB service set up. So we set the MongoDB service with name MongoDB container. We selected the version of our Mongo, right? We set the username and password for our MongoDB service, right? We also set the network. We created a custom network here. We also, okay, so that's for the Mongo. Then for the RabbitMQ, we also set up our RabbitMQ service here, right? We set up the default username and password. That's IoT Masterclass, Masterclass 1990. We set it up for the environment variables. We also put it on the same network. And then we opened the ports for the AMQP and the management ports, right? So the AMQP port is how we connect to the RabbitMQ to send our messages or receive messages, for connection. And then the management port, we can use it to create users and do all management related stuff, right? The management API does have some docs. You can use it to do a lot more. But that's what we're just using it to create users and do some setup in this application. So just to check, right? Our management port is on port 15672, right? So if we were to open our, for example, now if we were to open our browser, right? Copy this, right? Paste. And then we'll go to port 15672, right? So you would see that we have our RabbitMQ service hosted, right? And we can log in with our username and password. I should have put this in the environment variable, not sure. I guess I was rushing a lot to do this video, so I'm gonna just copy the username and the password and paste it there. So username, password is Masterclass 1990. And now we can log in. Now you can see that we have this set up now, right? So there's no connections at this time, right? Everything is just clean. We just have a clean RabbitMQ server running, right? We enable the port to be hosted outside so that we can access and see what we're doing. Now that's just an example of what we have set up there. Now let's go to our All API service. That one is on port 7000. So if you go to our environment variable here, this is why I was saying I should have routed the password from here, just, so that the password is not all in the YAML files, right? So I guess I was rushing and I didn't see that. So you can see our default port is port 7000. So if you go to port 7000, right? So let's go copy this API again, copy, paste that. And we want to go to port 7000. Now you can see it's there. It's just not, there's no page on port 7000. So if you type /docs, okay, now you can see we use Fast API. We have it hosted on our server. Everything's running, right, in our Docker environment. And you can see we have our authentication controller, sign up controller, profile controller, device commands, telemetry control, group control, user control, and just for health related purposes. If you want to check if your server is up, you can run this API and it should execute and tell you if everything just gives you a status of your environment. Just make sure that you can hit the API. And we're going to use that when we start working with Kubernetes, right? In case something is down and we want to spin it back up, we want to set something up to spin it back up, right? One of the pods is down, we want to spin it back up. All right, so you can see everything is locked, right? There's keys, apart from a few APIs like this ones, and those will use an API key usually, right? So you would need an API key to configure these. I think also, where is our WebSockets API? Okay, yeah, sorry, the WebSockets is a WebSocket, so it doesn't really show up. it's there. It just doesn't show up, right? So again, let me minimize this, right? So you can see all our services are up, right? All the services that we just used and if you go through the YAML file here, you would see, if you go through our YAML file, you would see all those services. So let me open up that again. Docker compose.yaml, right? So that's the all API, that's our RabbitMQ, right? This is our all API service that we just looked at. That's on port 7000. Device service, I think, is 7001. This should be 7000. Groups APIs service should be on 7002, and it's pretty much almost the same setup. It's running the same code, really. It's just we're building it separately. So if you look at the code down here, you would see that we have our main all. We have a Docker file for it, or so it's running each file, and each file just wraps in the APIs that we want to see. So here, this is the main all. So it wraps in, it includes the router for all the APIs that we want to see, right? So including the WebSocket, right? So you can see the WebSocket router there, right? So if you go to the authentication main auth, right? So this is the Docker, sorry. This is the Docker file. Okay, for example, if you go to the Docker file, you can see how we're running it, right? We take a Python 3.9, we create a working folder, we copy our requirements.txt in there, we run pip install so that it installs all our requirements so that you don't have to bother about reinstalling requirements. Everything's just installed, right? And if you go to requirements.txt, it shows all the requirements that we're using. We're using Fast API, PyMongo, Bicrypt, Jose, PyJWT, Pika, and Python.env for environment variables, right? So basically everything's set up there, right? So now, so basically, we copy our requirements, we install our requirements.txt, then we copy all the folders, right? All the folders in the application, excluding the ones that are in the Docker ignore file somewhere here. Yep, so excluding the ones in the Docker ignore. So these files would be copied over because they're not really needed for our Docker build, right? So that's been copied over. Then we expose port 7000. That's we're running this main auth 7000, and what you see here is 7000 is open on the Docker image, but then when you go to the Docker file for the main all, you would see that we then took the 7000. So basically in that port 7000 is open, right? Port 7000 is open, and then we open it on our default port, which is also port 7000 actually, right? So port 7000 is open in that pod, but then we open it in our default port, right? And so we're just putting it on port 7000. In the others, it's a little different. In the others, you might see, okay, like we put the default API on port 7000, but then we're exposing it for us to see on the authentication port, right? So if you look at this authentication API service, right, if we go to the environment variables, our authentication port is 7001, right? So let's say we open our API again, and instead of 7000, we type in 7001. We would only see APIs that are related to authentication. So that's the user authentication API and our sign up, how our users are going to sign up for our application, right? The next thing, so similar stuff, right, for everything, right? So if you go to the next one, this next one is for our devices API service, right? And it's in the Docker, it's on 7000, but then when we come to the port, it's on device port. And if you go to device port, that is 7002. Now, if you look at these Docker files, for most of them, they are all kind of almost the same. They're all almost the same. So let's go to the main devices Docker file. You see it's kind of just running almost the same thing as the other one. So it's copying Python 3.9, workup folder, copies the requirements.txt. Now, it's probably different in the other applications, right? But it's just copying the same thing as just exposing it to port 7000 and then running the UVCon to start the application, right? So everything's set up here. You can see how we hosted this very easily, right? So basically this is on port 7001. If you go to 7002, you would see our devices APIs, right? Just the devices APIs, you would see everything. Now, I left this authentication controller in all of them just in case, when you're testing an application, you just want to quickly log in and then use the APIs, but normally they shouldn't be there. The main one that the application uses is the one on the authentication service, or if you want to use everything on the main all app, you can do that also. Now, if you go to 7003, you will see a different controller for authenticate so a group controller, right? So you see a group controller is on 3. If you go to 4, you would see our telemetry controller, right? That's our telemetry service. If you go to 5, you would see our users controller, right? That's how we get all our users by ID or delete a user or set a user's permission or edit a user. And then if you go to 6, you would see this is our WebSockets API. So the WebSocket isn't showing, but it's hosted here on this 7006, right? So this is pretty much it, right? This is our API. We can look over the code at some other point, right? But for now, let's host the other applications. Okay, so let me go back. We have hosted our connector API. Now let's host our dashboard. Okay, so I'm gonna open a new bash terminal. And I'm gonna cd into dashboard. So now I'm gonna run those two commands again. So let's run those two commands again. So again, it's the same commands as we've run multiple times. So I'm just gonna build and run. You could just run this one the first time. It's just sometimes I build it so that I can take the latest and copy, right? So, but you could just run that second one alone since it's the first time. So it's going to build it and then host it, right? So Docker compose -- project, IoT masterclass, then up -d. -d makes sure that we can use our terminal. If you don't put that in, we probably, it'd be using the terminal to show, the status, right? So let's run that again. So now it's going to build and it's going to upload it with just that one command, since we don't have any copies of the image previously, right? So if we look, new images are going to pop up for our dashboard, right? So our dashboard image just popped up. You see it right here. And then our dashboard has been added to our project, our compose project called IoT Masterclass. So you see the dashboard up here, right? So it's hosted. What that means now is that our dashboard is hosted on port 80. So it's open on the main port, right? So if you go to dashboard and let's go to the YAML compose, you would see that our viewport is port 80. In the Docker file, it's hosted on 5000, right? So if you go to the Docker file, sorry, this is the environment variable for that board. Let's open the Docker file, right? So it's different because it's running this is running Node.js, right? The other ones we're running Python, right? So we're starting from this Node JS version. That's the version I tested with. That's the version I was using on my computer. So that's the version I just decided to put up there because I tested with it locally, right? And then we created a working directory, right? We copied our package to that package.json into that directory, right? We installed all the dependencies, right? You can do npm install, but I think the recommended way is npm ci. We run and installed all the dependencies that's needed. Once all the dependencies have been installed, we copied all the files, excluding the files that are in our Docker ignore, right? So these files will not be copied over environment variable. The environment variable we're setting on the Docker file, so we don't need to copy that file over, right? And then we did our npm start to start our application, right? Because this is a Node.js application, unlike the other Docker file, right? The main all Docker file where we used UVCon to start the application. So this starts the application in the Node, right? In the Docker. And then once that started, then, this is our dashboard container YAML file, right? So dashboard YAML. And, it's saying that restart always. So anytime it crashes, just make sure it comes back up. And then we set all the environment variables that are needed, right? And then we're opening it on port 80. What that means is that it is our main interface into our application, right? So if we just copy this, our IP address, and we paste it and go, just the IP address, you would see that our application is running. Hooray! Now, isn't that cool? So you can see that the application is running. We're in the login page. Our platform APIs, platform dashboard is set up, and basically you can start using the application. Now, remember, we haven't set up the event hub yet. However, the function of the event hub is to get messages that were transmitted from or that were sent from the Raspberry Pi. So at this point, though, the application itself, the web application, is already up and running. Now, by default, there is a default user. And if you look at the environment variable, you would see that, right? There is a default user, and the default user is admin@admin.com, and his password is admin. Now, after you launch this, you can always reset that password in your database. However, when you launch the application the first time, you can log in with admin@admin.com with password admin. So let's try that. So we can say admin. Now, first of all, also you can register a new user. So you can create a new user. When you create a user, the user initially comes with the default viewer permissions, right? Because you don't want somebody to just create an account and just have access to everything, right? So viewer permissions, though, for this application, I would say is pretty high. Normally in applications I've developed, if you wouldn't really see anything until you start getting access. But in this application, I just thought that, this is just a test application to just put out there for people to try, right? And if somebody wants to create a user, at least let them be able to see something. They might not be able to do anything with what they see, but at least they see there's some stuff in the system, right? But the admin user is the higher version of the user. So we're gonna sign in as an admin, adn@admin.com. And now let's sign in. Now, if everything goes well, which it should, right? We should be logged in, right? You can see this is our application, right? Now, it has a sign out button here. If you click on it, it tells you if you want to sign out. So just a note, this application was put together in about a week and a half. So please, I didn't really have much time to go through stuff. I just put things anywhere I could find to put them and, just got things going, right? Now, basically, you can sign out from there. This is the user that signed in and his name, right? This is the groups UI, right? So in the group UI, the idea behind the groups UI is that you can group sets of devices together. So if you had like 20 devices and you wanted to put them on a particular group, right? Maybe your kitchen is a group, or maybe my home is a group, right? A group could generally be anything. It helps you categorize a lot of devices together and append them into a group, right? So basically we could create a group, right? We could say kitchen group, and we can set the parent. It doesn't have any parent group. It's just kitchen group. Location is my home. You don't need to type all this. They're not really needed. Type an address and create. Now you could see success kitchen group has been added to the system, and there is my kitchen group, right? So you can edit it if you wanted to change the name, or you wanted to change the location, or you wanted to change the type or the address. and you click edit, or you can delete it using the delete button, right? So the application is a simple application. It's just set up to be easy, right? Easy to use, easy to set up, right? Now, the other thing you could do, you can go into groups, right? And in groups, you could see here right now that there is the option for devices, right? So you can create your device. You could say, all right, I want a new device. Let me create a new device, and I will call it, let's say lamp 1. Lamp 1. And location, it could be my kitchen or my counter. You don't have to really put that, right? Now, there is no parent device for, okay, yeah, this is good. So maybe not create lamp 1 yet. Like, you can have a lamp that's directly connected to the platform, but the general use case is usually preferred way is everything connects to a gateway, and then that gateway is what really connects all the other devices together. So you can have a parent device that then has sub-devices connected to that primary or that parent device. So in that case, let's say we have a gateway 1. A gateway 1 device, right? Location is in my home, right? And parent device, it's a parent device, so it doesn't have a parent device associated with it because it's the main device. It's the highest level of device that you could have, right? Now, we could say it is a gateway, right? So the profile we would leave at default, right? For now. Right? It's not a lamp, it's not an LED, it's not a sensor, it's not a humidity, it's not a temperature, and it's not a motor. The different profiles that are created by default. And you would see later that you can add more profiles. These are the default profiles that come with devices, right, for this system, but you can add more profiles later. And profiles are generally like maps of the way you send data. So when you say a device profile, it tells you more like, these are the types of data that I want to send with this device. And we'll talk about that later, right? And then this type of device is a gateway. And then I can now create that. Success, gateway 1 has been added to the system. All right. Now, let's say I want to add a lamp device, right? So lamp, and that lamp is on my kitchen counter. And now the parent device of this lamp is my gateway 1, and it's a lamp, and the type of device is actually a light, or let's say it's an LED lamp, right? And I create, now you could see that we have a lamp device, and that type of lamp, it's a lamp, right? It's an LED lamp, and it's connected to gateway 1. It's part of our gateway 1 profile, right? And you can create as many gateways as you want and as many devices as you want. Doesn't really matter. Now, let's say, let me edit this to maybe red lamp, right? Or let's say lamp 1. Let's just say lamp 1 so that we can create a new lamp and call it lamp 2. And we can say edit. Now we've edited the name to lamp 1, right? Now let's add a new device and we'll call that lamp 2. Location is still kitchen counter. Parent device is gateway. Profile, LED, right? It's an LED lamp. We'll just say both LED, right? So both are LED. Okay. Oh, okay, we used lamp. Well, it's the same. So let's say we can say lamp. We can call this profile for lamp. Okay. These are just default profiles anyways. You can change them as you want, right? So you can see, you can also add a sensor if you have a temperature sensor, a humidity sensor, right? So let's say we have a sensor, temp, sensor 1. My keyboard is acting up. I don't need to put the location. We already know where it is. We'll add it to gateway. We'll make it a sensor. Device type is sensor, right? Profile is sensor. We could also say our profile is humidity. Well, we'll just use a sensor for that. Okay, sorry, not humidity, temperature. Why did I thought I created a humidity sensor. Okay, but we'll just say sensor for now, right? And now you'd see here that we've added temperature sensor 1 to the system, and it's typed as sensor, profile sensor. So basically you have a way to group your devices within your group, right? And also tie your devices to a particular gateway. And these infrastructure is really important to the way your data comes in, right? If you wanted to view data coming in from your devices, all you have to do is just go to your telemetry view. You can see like those profiles that we set up gave it the type of data that we want to see. So for our gateway, the default just tells it that there's a state. So usually states are like on or off, right? For the lamp, the state also be on or off. But then there's also a brightness state. Those profiles are what tells us what we want to see. And you'd see it after we connect our Raspberry Pi in, right? So this lamp, this is the lamp's brightness. This is the state. This is the state for lamp 2, the brightness for lamp 2, and sensor, the value for the sensor. Now you can connect to the WebSocket. Since our event hub isn't on yet, we won't see any data, but basically we can connect at this point because our API service that hosts our WebSocket is already set up, right? So right now it's connected. There are no issues. If it's not connected, it will give you an error message. So right now it's connected, but we don't really need that right now. So let's go back. So basically you can set up your groups with your devices and map your devices like you want. You can create a group, right, and edit, do whatever you want, right? You can also see your telemetry data. There's also a second view here for telemetry, right? And you can see here, like when you click on this here, it loads the first one on the list, right, which is our kitchen group, right? So you can directly just go to your dashboard without having to go through the whole application, right? So it's pretty easy to use. Now here, this is our system access. And because this user is an admin, right, the admin kind of sees everything going in, right? You can change your password if you want to change. If the admin wanted to change his password, he can change his password. That's why I told you, you can, it comes with a default user, but at some other time you can change your password and, just deal with it. Now, I don't know if I tested everything, but most of it is working. So, but just enjoy it. Just try it out. It's just a test application, not really anything. It just shows you how to build something similar and just look at the code and see how things work, right? Now, there is also a device router. Now, this device router was created by default, and you would see that really it's embedded in the code. You can change that password. You can modify the code to change, but really we don't want to be able to give a user access, even the admin access to change this. This needs to be someone who really knows what he's doing, not just an admin, more like the person who hosts the system, right? Needs to understand, who knows everything about the system, needs to know what he's doing, because this device router is the password that our Event Hub is using. That this is our Events Hub username and account, right? That's why it's called the device router. It routes messages from one point to another, right? From our RabbitMQ down to our IoT application. Now, let me not bore you with details, but essentially you can even edit a user's profile, right? Right now, this user is admin. I could make him a viewer because I'm an admin, but I don't want to make myself a viewer. If I do that, I would lose access to everything, right? And that would be crazy, right? But let's say a new user was created. You can come here and edit the user, maybe step him up or step him down, whatever you want to do. But just shows you what you could do. Now on a real system, you would probably want to have multiple levels of accesses, right? So that users can't just access anything, right? And again, right, users should be able to access groups, right? So basically, if you click on that user, you saw how I clicked on this particular user. So it shows what group can this person access. And you could see that he can access the groups that are, like all the groups, as long as any group is created, an admin can access it, right? If you create a new account, that user will be here, right? That user will be here. Now, you don't have to give that user full access to everything, right? You could click on that user and then go in and give the user access to a particular group that you created. So you can click on that user and go in and give that user access to a particular group. And that user will only be able to control things within that group. So the devices in that group, you might be able to move them around or even see the data from that group, right? But he can't do anything more than access what is in that group, right? So when we talk about permissions and our our platform, right? You really have to be able to know what you're giving your users access to, what services they can access, and you have to be able to control that properly from your panel, right? So this kind of gives that user the ability to do that. So there are different groups, right? It doesn't have a parent group. It's in my home location. As more groups are added, you would see this list kind of go down. And then the last thing here is profile, right? So we talked about the default profile. So I was just thinking, in my head, I think all the time, crazy me, and I was thinking like, okay, what kind of default profiles would we want to have, right? So there's a default profile. Maybe every device comes with a default profile, who knows, but when you're designing your system, you can try to figure that out, right? And then we have this lamp here, right? The type of device called a lamp, type of device called LED. They're probably the same profile. If you look at the profile, you'll see an LED has a state, it has ping, it has brightness, right? So those were the things you saw on that dashboard, except the ping. The ping was something that maybe we want to hide, because we want to use it to ping the sensor and see, or the device, and see if it's actually there or not. So it comes with, some types of devices. If you want, you can add more states if you create more. You can create a state and add it. But for this system, you can also delete the profile, right? We have the option here to delete. You can see this is the profile for the motor, right? It has a state and a speed. I'm not sure why I didn't add the ping, but who knows? You can see the temperature. The temperature only has a state for temperature. You could see our humidity. It only has a state for humidity, right? You can see our sensor only has states for sensor. You could see our LED and our default. Default just has state. And the type of data also matters, right? The ping is a Boolean variable. State, you can create your states and use them however you like, right? So feel free, enjoy the application, and just, give me feedbacks, right? Now let's go on. This is taking longer than I expected, actually. Okay, so let's not spend much time into this. This is just an overview of that desktop application. Now let's finalize and host our event hub. So for the event hub, again, we're going to run the same thing. So the same things we ran before. I'm going to create a new terminal here, bash terminal, and I'm going to cd into event hub. And now I'm going to run that Docker command again. Paste that. And now, while we're doing that, we can go here. So now you can see we don't have our event up running yet, right? So now when we run this, is our event up here? Yeah, I think it's done. It's a very small application. It's probably the smallest of them all, right? So you see the image for the event hub service is up, right? And you can see our event hub service. It's up here, right? Now we can go, let's attach let's see the logs, right? So you can go and see the logs. So you see in our event hub service, it's running on port 780. I don't know why I put it on 780. So if you go to the Docker class for that, right? Different applications running on different ports in their application. You can run them all on the same port. I guess, sometimes when you run local, you want to use different ports so you know where things are before you finally host them, right? So if I went in here and I go to my Docker class, you can see here I'm exposing port 780. Right, so I ran it from the Node version on my computer, which is what the Docker is running on, right? It will pull it from the Node, and then work it directly. We'll create a working directory. Then it'll copy the package.json, run and install all the requirements in package.json, copy all the files, excluding the files in the Docker ignore, right? And then start the application using npm start. Now, if you look here, there is like 4 things here, right? So essentially, if you go into the code, right? So let's go into the code. Let's see a little what's happening in the event hub, right? Let's go to app.js. Now, if you open app.js, you'd see that we created a consumer class that's listening to our RabbitMQ server, right, for messages. And, we talked about fan out messages earlier, right? We talked about fan out messages where basically, it's anytime there's a message, it will send to all the exchanges that are on the fan that are connected, right? So it was sent to all of them. So now the only difference is this for, so basically we have for loop, right? There's 4 of them, right? Total consumers is 4. And we're running a for loop and creating 4 different consumers, right? Consumer 1, consumer 2, consumer 3, and consumer 4. That's what we're doing here, right? And when we run those 4 consumers, anytime there's a message, usually it will send to all 4. But we set it up in such a way where it's fair, right? We don't just want it to send everything to all 4 and they all working at the same time. But we don't want it to just maybe have a round robin and just send to the first one, send to the second one, send to the third one, send to the fourth one, and then repeat again. We don't want it like that. We want something that's fair. So, and if you look at the code, we set it up in a way where when there is a message, it sends it to one of the consumers, but until that consumer is ready for the next one, right? So until it's ready for the next one, it won't receive anything. So basically, it'll send to the first one. When there's a new message, instead of sending to the first one, if the first one is not available, if it's still working on the initial message, it sends to the second one. And then when there's another message, if both of them are not available, it sends to the third one. And then that's what it will keep doing. And then if any of them become available, then it will send to the first one again or to the second one. Whoever is available at the time, right, is who it will send to. That way we can assume that it's fair, right? We talked about that. We talked about that here, right? Where we have a fair task work queue for our exchange, right? So read up on this as much as you want. But essentially right now, our Event Hub service is working. And it's connected to our RabbitMQ. Now, if you go to our RabbitMQ, so you can see that the number of consumers here is 4. So there are 4 consumers listening right now on this RabbitMQ. And whenever there is a message, right? Whenever a message comes in, it will route to any 4 of these, right? So that's pretty much the setup, right? This is the setup, right? So again, there's other things tied to this, like, not only, do we have, like, we can send messages. Oh yeah, I probably didn't show that, but if you go back here, right, to our group here, you would see here that we can send a message to a device, right? We can select a device. Let's say we wanted to send a message to lamp 1. We would say, okay, we want to set the brightness or the state, right? Now we want to set the state. Anyway, like, this application is a test application. It's not a real world application. So whatever you do, you could try it out, see how it works for you, test things out, and, enjoy. That's what I would say. Right. So again, this is just the setup. At this point, we've hosted 3 different things. We've hosted our connector API, we've hosted our dashboard, and we've hosted our event hub. Now, we're going to stop this video here. And in the next video, we will connect our Raspberry Pi. We would install our Raspberry Pi, connect it, and start sending data to our IoT platform. And it's pretty cool. Everything works out really smoothly, and I hope you enjoy this series. Again, thank you so much for listening to this video, spending this time. I know it's a pretty long video. Again, please feel free to like, comment, share this video, and I'll catch you in the next one.